Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to be working on the electron configuration of oxygen question. The first thing you have to do anytime you're given an electron configuration question is to determine the number of electrons of the atom. So we're supposed to determine the number of electrons for oxygen atom. Now, before we go ahead to do that, we have to remember that for atoms, the number of protons and the number of electrons are exactly the same. So, for example, if the number of protons of an atom is 15, then the number of electrons for that atom is also 15. Aside from this, we also need to know another law or rule in the periodic table that says that the atomic number of an atom and the number of protons of an atom are exactly the same and have the same value. So if the atomic number is 54, then the number of protons has to be 54. So what this is telling us is that when we when we have the atomic number, then we can determine the number of protons and then we can determine the number of electrons. So looking at our periodic table, make sure you have it beside you. You will see that the atomic number for oxygen is 8, which makes the number of protons for oxygen to be 8, which makes the number of electrons for oxygen atom to be 8. Hence, the number of electrons for oxygen atom is 8. So that's the first thing. So now we've determined that the number of electrons for oxygen atom is 8. The next thing we have to do is to look at the energy orbital diagram. The energy orbital diagram is the diagram that is used in order for us to determine the electron configuration. And we start from the lowest energy orbital, which is 1s, to 2s to 2p. We basically start from the lowest in until where all electrons of the 8 electrons for oxygen is used up. So we start from the bottom. Each one of those orbital represents a box in this particular diagram, and we only can put a maximum of 2 electrons per box, hence 2 electrons per orbital. So we have 1, we've got 2, so we have 6 more electrons from 8. We've got 3, we've got 4, we've got 5, we've got 6, we've got 7, and we've got 8. So what we end up with is 8. Now, before we go on to do it, I need to teach you guys something. As you can see, the p orbital has 3 suborbitals. You got 1, you got 2, we got 3. Anytime we have a situation like this where an orbital has where we have like an orbital has like multiple suborbitals of the same energy level, we have to always fill in each box or each orbital first before we pair up, because electrons, as you know, are negatively charged, and it would not make sense for us to put two of them in an orbital while the other ones are empty, because of is we're going to end up with energy destabilization, because since the electrons are, both of them are negatively charged, like charges repel each other, so they're going to repel each other, forcing each one of them to end up into another orbital before we are now in a situation where we can pair them up. And in this case, we got to pair one of them up, and we've used up all 8, so we're done. So now the next thing we have to do is to write out what 1s is. So this is 1s2. Okay, we've got 2s2. These 2 represent the number of electrons in the orbital, and we have 2p4 because we've got 4. We've got 2 in the first orbital, 1 in the second, and 1 in the third, making 3 of them in total. So what we end up with is going to be 1s2, 2s2, 2p4. Now, to determine and make sure that you got the answer correct, you have to make sure you follow the orbital from the lowest energy orbital, so from 1s, 2s to wherever it's filled up, and you have to make sure that we used up all 8 of our electrons properly or correctly. And if you count the number of electrons up top, you have 2 plus 2, 4, 4 plus 4 is 8. So this our answer is correct. And the electron configuration for oxygen is 1s2, 2s2, and 2p4. I wish you guys all the very best. Make sure you hang around and watch more videos. Assalamu alaikum wa rahmatullahi wa barakatuh.